Okay, this is, for some of you, this is going to be quite a hard concept, and I have thought this through a lot, and I'm going to do my best to explain the different kinds of bonds and forces of attraction that we need to get our heads around in level 1, both chemistry and physics, to be fair, because you use this idea both in the heat topic and in carbon chemistry. So here we go. And for those of you who are doing level 1 science at the same time, this may be before, you may be doing this now before you actually do it in science. So please don't panic that it's too hard. This is what I'm about to explain is straight from the level 1 acids and bases paper. So what you can see in front of you is 2 atoms, 1 sodium and 1 chlorine, and the little crosses represent the electrons. So in sodium here, you've got an electron configuration of 2, 8, 1 with 1 valence electron, and in chlorine here, you've got 2, 8, 7. So 2, 8, 1, and chlorine 2, 8, 7. So what you should remember from level 1 is that what atoms want to do is to be in their lowest energy state and to be stable. And for them to do that, they want a full outer shell of electrons. So you can see sodium here has 1 valence or outer shell electron, and so it's very highly reactive because of that 1 electron. Okay, it's trying to lose that 1 electron so it can have a full shell. Whereas chlorine here has got 7 valence electrons, so therefore it wants to gain an electron to become to have a full outer shell and become stable. So what happens is sodium here actually gives its valence electron to chlorine. And in the process, what happens is that an ion, ION, is created. And so we get Na plus when it loses this electron. When chlorine gains this electron, it also becomes an ion, Cl minus. Okay, and as a result of that, we get the compound NaCl, or sodium chloride, forming. Okay, now that is neutral, it has no overall charge, and it's stable. And what's really important, the reason I'm explaining this is because when we have a positive ion and a negative ion here, we get a force of attraction. And somebody did mention that it was an electrostatic force of attraction. And that force of attraction is so strong that we call it a bond. And in fact, it's an ionic bond. So that's what an ionic bond is. It's the electrostatic attraction between the positive and the negative ion, created when 1 electron is transferred to a different atom. And it can be more than 1 electron, it can be actually up to 3 electrons. Okay, so that's an ionic bond. Now we're going to look at something a little bit different and a little bit new. So this next part is new for everybody. So what I've got in front of you now is 3 different, hopefully recognizable atoms. I've got 1 hydrogen here, which only has 1 electron, another hydrogen here, which only has 1 electron, and oxygen, which actually has 8 electrons, organized in the electron arrangement 2, 6. Now it gets a little bit tricky here, because if hydrogen gave away its electron to oxygen, that might be quite good, but hydrogen would be left with no electrons, so that's not going to work because it's not going to be very happy. Remember that all atoms want to have a full outer shell of electrons. And the same here. So what happens in the case of all non-metals is that instead of giving their electron away, they share electrons. So these 2 electrons here are shared between the hydrogen atom and the oxygen atom. And as you can see, if we share them, Okay, then this hydrogen atom has these 2 electrons and has a full outer shell, if you imagine the hydrogen really close together. And same here. And the oxygen also then has 8 electrons, the 6 of its own and these 2 here. So they share electrons. Now that still creates a bond, and in actual fact that creates a bond that is stronger than an ionic bond. And this sharing of electrons is called a covalent bond. Now you do not need to be able to explain this concept for the heat topic, but you will need to be able to explain it for the carbon chemistry topic. So I need to introduce it now because I need to introduce you to the difference between bonds and forces of attraction. So far we've got 2 kinds of bond. We've got the ionic bond that those of you who've done level 1 science will have seen before, and then this new one, which is a covalent bond, and it's when valence electrons are shared. Okay, that's all you need to know at the moment. So I'm just going to put that to the side and have a look here. So what I've got here is another representation of water. This is called a Lewis diagram, and those of you who are going on to chemistry at level 2 will look at these in much more detail than we are going to look at it right now. And this is an understanding / background explanation. So the 6 crosses that you see around oxygen are the 6 valence electrons, and you've got the 2 hydrogen electrons, or the individual electrons for each hydrogen atom here. And as you can see, if we put those 2 together, we've got each hydrogen atom having a full outer shell of electrons because they have 2. And then if we put another circle around all of these, we've got oxygen having a full outer shell of 8 electrons as well. The difference is that these ones are shared. So they're shared electrons. That's my little shorthand for electrons. And so it creates a covalent bond. Now you might be wondering why, I'm hoping you're wondering why, I've drawn this as a V shape. Okay, now electrons, as you can see, are in pairs. And I wonder whether you've ever asked yourself why electrons are in pairs when you know that negative charges repel. Well, that works because these spin in opposite directions. Remembering electrons move really fast, they spin really fast. Well, one spins clockwise and one spins anti-clockwise, and that's why they can pair. However, this pair of electrons is repelled by this pair of electrons, which is repelled by this pair of electrons, which is repelled by this pair of electrons, which is why you get that shape. And what it means is that that water then becomes a V-shaped molecule. Now again, you won't be asked this in the end of your exam. This is background information to help you understand what we're about to go on to. So it's a V-shaped molecule. Now because there's a lot of electrons up here, this end of the molecule becomes very slightly negative. Okay, and so by default, this end of the molecule becomes a little tiny bit positive. Now, if you're searching this up, you might hear the word polarity. You don't need to worry about that until level 2. So this is the negative end of the molecule, and here we've got a kind of a very tiny positive end. Now, that's important for us because, I'm going to just change to a new piece of paper. When you've got a whole lot of molecules of water together, okay, you start getting what's called forces, weak intermolecular forces. So these big, thick black lines that I've drawn are the bonds. They're covalent bonds. But you've also got forces of attraction between the positive and the negative ends. Okay, and so that's what holds the molecules together in a solid. Okay, So those things there are called weak intermolecular forces. And from this point on, I'm going to call them WIFs. Okay, so they're forces of attraction between molecules, whereas this black line here is a covalent bond, that is the sharing of electrons within a molecule. Sharing of electrons within a molecule compared to a weak force of attraction between molecules. If you think about it, here's one molecule here. Here's another molecule here. One molecule, two molecules. This is within the molecule. This one is between the molecules. Really, really important concept there. So those WIFs are what hold water together in a solid and a liquid state. So I'm just going to show you, I'm going to stop it there because I think that's more than enough for you to take on board. Please replay if you need a bit, if you need it explained again. Thanks, people.